Okay, so today we start Cauchy sequence. Okay, so definition. So when we say a sequence is said to be Cauchy sequence if after certain stage all the sequence elements are very close. Definition: a sequence xn, a sequence xn in R is said to be Cauchy. Is said to be Cauchy if, when we say a sequence is Cauchy, if you take any epsilon greater than 0, there is a stage. That is, there is some n naught in n such that after this n naught, all the xn's are very close. Such that for all, if you take any two indices, that is m comma n, which is greater than or equal to n naught, we have the distance between xm and xn are less than epsilon. So we have modulus of xm minus xn is strictly less than epsilon. So that means what? After certain stage, all the sequence members are very close. So very close means what? The difference is very small. Okay. So that is a definition of Cauchy sequence. So suppose that means what? Suppose you are mark all the sequence elements. Suppose x1 is here, x2 is here, somewhere x3 is here, x4 is here, and x5 is here anyway. So and so on. So after certain stage, all the sequence members are very close. So all the xm, xn, all the things are very close. Very close means what? Distance between any two sequence numbers are very small. But we cannot fix any element here. After certain stage, all the sequence members are very close. That is that sequence is called Cauchy sequence. But if we take xn equal to n, this sequence is not Cauchy sequence. Why? Because if you take xm minus xm, or if you take the next two elements, so this is nothing but n, or if we take better, this is n plus 1, this is n. So this is nothing but n plus 1 minus n, this is nothing but 1. But if I choose, this is true for every epsilon. Suppose I am taking choose epsilon equal to 1 by 2, but this is not less than epsilon. Therefore, this sequence is not Cauchy sequence, because after certain stage, if you take any stage, the difference between any two elements is not less than epsilon. It's always 1 or more than 1, because all are integers. Therefore, the difference always minimum 1. So if you choose epsilon is 1 by 2 or 1 by 3, this definition will not work for this sequence. Therefore, this sequence is not Cauchy sequence. But if you take a 1 by n sequence, xn equal to 1 by n, so that if after certain stage, because this is 0 and this is 1, suppose this is 1 by 2, first, second point, and so on. So after certain stage, everything very close to 0. We know that all the elements are very close to 0. Therefore, if you take distance between any two points in the sequence, always less than epsilon. Okay. So this is a definition of Cauchy sequence. Now there is some criteria for Cauchy sequence. So first example, if you take any convergent sequence, is always Cauchy sequence. That is a theorem. If you take any real convergent sequence, any real convergent sequence is Cauchy. Convergent sequence are always Cauchy sequence. But a Cauchy sequence need not be converges. If it is Cauchy sequence is converges, any Cauchy sequence converges, we say that set is called the complete set. Okay. So it's Cauchy. So this is a theorem. Okay, very important theorem. Any convergent sequence is Cauchy sequence. So how to prove this one? Suppose we have a convergent sequence xn is converges to some point x. Okay. Now what we got to prove? We got to prove this xn is Cauchy. That means what we got to prove? After certain stage, these xn's are very close. So that means we have to estimate the distance between xn and then xm is less than epsilon. Okay, so given epsilon greater than 0 is given. So since xn converges to x, therefore given any epsilon, there is a stage n naught in n such that modulus of xn minus x is less than epsilon whenever n greater than or equal to n. We know this by the definition of xn converges to x. Now we have to estimate this xn minus the difference between the sequence members should be less than epsilon. Why? Suppose I am adding and subtracting x. Therefore, xn minus x plus x. Suppose I am adding x and then subtracting minus xn. And we can apply the triangle inequality. We get a xn minus x plus modulus of xm minus x. Because we know that modulus of a plus b one less than or equal to modulus of a plus modulus of b. And then modulus of minus a is nothing but modulus of e. Okay, therefore we can take minus to this term, we get a modulus of minus nothing but plus and xn minus x. So we know that this is to for every n which is greater than or equal to n. So in this case, suppose what is the relation between this n and m? Suppose we assume that n is bigger than m. Now we can choose what is the stage. You can choose the same stage where xn converges to x. You can choose the same stage which is n naught. So if you take any two elements after this n naught, the distance is, so this is for every epsilon. So in particular take x by 2. So therefore this is equal, this is less than x by 2 for the first term. This term also less than x by 2. Okay, please wait. Once again I share my screen. Okay. Stop. Okay, so now we have a approximation. So for xn minus xm, okay, so we can add and subtract x. You will get modulus of xn minus x plus x minus xm. Apply triangle inequality, we get less than or equal to modulus of xn minus x plus modulus of xm minus x. Because you take minus common, that's why we get this is minus x. Okay. Now assume that this n is bigger than m. So choose the same stage where you get stage in that xn converges to x. So this is for every epsilon. In particular, take epsilon 2. Therefore, this is less than epsilon 2, and this is also less than epsilon 2. So because this is true for any n greater than n naught, so since this n is also greater than n naught, this m also greater than n naught, therefore this is epsilon by 2, this is epsilon by 2, therefore this is equal to epsilon. Therefore, the distance between xn minus xn is less than epsilon for any n comma m which is bigger than or equal to the stage. Okay, therefore xn is a Cauchy sequence. Therefore, every convergence sequence is Cauchy. It's very important. But Cauchy sequence need not be convergence sequence in general, but in the real case, every Cauchy sequence is convergent. That is the next theorem. That theorem is called Cauchy completeness of R. That is completeness of R. But in general, Cauchy sequence need not be convergent. I will give example. Okay, but in the real case, that is true. Theorem. That theorem is called Cauchy completeness. Cauchy completeness of R. So what the theorem says, a real sequence xn is Cauchy if and only if it converges. If and only if it is convergent. So even if you take complex sequence, Cauchy sequence always convergent, convergent sequence always Cauchy. Okay, but in general space, we cannot say Cauchy sequence is converges. Okay, so if converges, the converges point also in the set. That is very important. Okay, so why if it takes some okay, now maybe I will give some example why convergent sequence, sorry, why Cauchy sequence not convergent. So convergent means what? The convergent limit should be in the set. So suppose for example, I am taking the set A is open 0, open 1 in the interval. Okay, interval 0 to 1. I am taking the sequence xn in this. So if you want, you can take close to a 1. Suppose I am taking the sequence 1 by n. Okay, so this is sequence in A because all the members are inside A. This is a convergent sequence because we know that this converges to 0 in R. Therefore, we can easily show that this is a Cauchy sequence. The difference between 1 by n minus 1 by m, we can easily prove that this is less than epsilon. So, because all the 1 by n's are very close to 0, therefore we can find the distance between any two 1 by n's are less than epsilon. Therefore, clearly this is Cauchy sequence. Cauchy in the set A. Because we take sequence from A. Therefore, this is Cauchy sequence in A. But this sequence not converges in A. Why? Because this 1 by n converges to 0, but 0 is not in A. Therefore, this is not Cauchy sequence in A, but not convergence in A. Therefore, in general, Cauchy sequence may not be convergent sequence. But if you take a whole R, every Cauchy sequence is convergent, convergent sequence is Cauchy. Okay, so that is very important. So if you take this set open 0 close to 1, if you take this sequence, this is a Cauchy sequence, but not convergent in A, not in R. Okay, in R this is convergence and this is Cauchy. But if you take this particular set, this is not convergent. Okay. Now, next, any Cauchy sequence is bounded sequence. Next theorem. Even the sequences converges or not, but if we take any Cauchy sequence, is always bounded. Any Cauchy sequence is bounded. We can find a positive number m such that modulus of xm is less than m. So that is trivial. So we can choose epsilon. So given that xn is Cauchy, suppose if we take xn is a Cauchy sequence, we have to prove that xn is bounded. So that means we have to find m positive such that the modulus of xm is less than or equal to m. We have to find such an m. So since this is Cauchy, therefore for every epsilon greater than 0, there is a stage n naught in n such that after this stage, if you take any two elements, the distance between xn minus xm is less than epsilon. So this is true for every n. In particular, I am taking epsilon equal to 1, and instead of taking m, I am taking the next term maybe some okay, suppose take epsilon equal to 1. Therefore, this is equal to 1. Okay, so I am taking there are two numbers. Suppose I am taking this equal to this fixed number, m equal to m. So therefore, what you will get xn minus xn naught is less than 1. Now this is nothing but if minus 1 less than xn minus xn naught less than 1, just add xn naught both sides. Therefore, we get xn naught minus 1 less than xn less than 1 plus xn naught. Since n naught is fixed number, therefore xn naught is known number. Okay, so this xn, now we find that modulus of xn is less than 1 plus xn naught. So this is true for every n greater than or equal to n naught. So therefore, all the xn's are bounded by this number for all n which is greater than or equal to n naught. But what about the previous terms? So we missed how many times we missed? X1, x2 up to xn naught minus 1. These terms are we missed. But after this, that xn naught plus 1, all these terms are bounded by this number. But what about this number? We don't know. Therefore, we have to choose m equal to modulus of the first n naught minus 1 numbers. So m equal to maximum of, so already we take this element 1 plus xn naught and then take the modulus of the remaining numbers. Now this m will satisfy the condition xn is less than or equal to m for all n. So therefore, this sequence is bounded. Therefore, every Cauchy sequence is bounded sequence. Okay. Now, naturally, we can ask question: bounded sequence or Cauchy sequence? Converse. Okay. What can you think about this one? Is the bounded sequence or Cauchy sequence? No. Why? Can you give some example? Should be bounded and but not Cauchy. But not Cauchy means what? After certain stage, the distance between any two sequence members are, which is not small. It's not small. So can you give example? Can you give example of a bounded sequence but not Cauchy? So the standard one is you can take xn equal to minus 1 power n. So what is the sequence elements are? 1, minus 1, 1, minus 1, 1 and so on. So this is a bounded sequence, right? Bounded by 1. That is each xn is less than or equal to 1 for every n. Therefore, xn is bounded. Why this is not Cauchy? But anyway, if it is Cauchy, this is a real sequence, should be converges, right? Therefore, this is not we know that this is oscillation sequence. It's not converges. Therefore, clearly this is not Cauchy, but bounded. Got it? So this is a bounded, but not Cauchy. Why is not Cauchy? If it is Cauchy, we know that every Cauchy sequence of real numbers should converges. But this sequence is not converges, this is oscillate sequence. Therefore, the converse need not be true. Bounded sequence need not be Cauchy, but the Cauchy sequence always bounded. Okay. Now, there are some problems. So the first problem, suppose we have a two Cauchy sequence. If the sum of two Cauchy sequence and the product of two Cauchy sequence is always Cauchy. Okay. So maybe I state as a theorem, or we can take the problem. Suppose we have two sequence xn and yn. B Cauchy sequence. We have two Cauchy sequence. Then this xn plus yn, this sequence and the product xn into yn are Cauchy. So sum of two Cauchy sequences is Cauchy, product of two Cauchy sequences is Cauchy. We can easily prove it. Okay. So how to prove the sum of two Cauchy sequences is Cauchy? So we have to take this. So suppose I'm called Zn. Zn equal to xn plus Zn. So what we have to find? We have to find the distance between Zn and Zm. Should be less than epsilon. So this is equal to Zn is xn plus yn minus what is Zm? Xm plus ym. You can simplify in adjust. So first you take all the xn term. So xn minus xm plus yn minus ym. Now apply the triangle inequality, we get modulus of xn minus xm plus modulus of yn minus ym. So therefore for this sequence xn, we have some stage, okay, n0. For this yn, we have some other stage n1. You take the maximum of these two, that is called some capital N. So capital N equal to maximum of these two number. Therefore this stage will work for this number. Therefore this is less than, we can take this is less than epsilon by 2, this is epsilon by 2, therefore we get less than epsilon. Therefore this Zn is Cauchy. Zn is nothing but xn plus yn. Similarly, for this we have to adjust. Therefore product of two Cauchy sequence also Cauchy sequence. Now I will ask one question. Next question. Suppose we have a sequence xn such that satisfy the condition modulus of xn is less than or equal to 1 plus n by 1 plus n plus 2n square for every r, for all n in n. Show that xn is Cauchy. Show that xn is Cauchy. So how to show xn is Cauchy? Already yesterday we proved the result. What the result we proved? Suppose we have the relation like modulus of an minus a is less than or equal to bn, where bn is positive and bn converges to 0, then an converges to a. We know this. Yesterday we discussed about. Now look at this is our bn. Here our an. A is 0. So we can rewrite its modulus of xn minus 0 is less than or equal to 1 plus n by 1 plus n plus 2n square. Anyway, n are natural number, therefore this is bn. These bn's are always greater than or equal to 0. Because if substitute n equal to 1, you get a positive number. If substitute n equal to 2, you get a positive number. Therefore, all the bn's are positive. Now, where this bn converges? From numerator, we can take n outside. Therefore, 1 plus 1 by n. In the denominator, we can take n square outside. So therefore, 1 by n square from the first term. The second term we get 1 by n. The third term we have a 2. Now we can cancel 1n. Now as n goes to 0, anyway n goes to infinity, this term goes to 0 and this term goes to 1, therefore this is 1, but we have a 1 by n term here. Therefore don't bother about this term, wherever it's may, but this 1 by n takes to 0. Okay, therefore by previous result, xn converges to 0. Because this converges to 0, since this is of the form modulus of xn minus 0 is bounded by the 0 sequences, converges to 0 sequence, therefore this xn converges to 0. Since xn is a convergent sequence, and we know that every convergent sequence is Cauchy sequence, therefore xn is Cauchy. Okay, now I am asking one more very important question. Just think and answer. So second question, suppose we have a sequence of integers. That means what? The sequence contains only the integer entries. Suppose xn is a Cauchy sequence as well as Cauchy sequence of integers. Cauchy sequence of integers. Then what can you say about the sequence? Xn is a Cauchy sequence and every sequence terms are integers. Then what can you say about the xn? What is the sequence? So you know the definition of Cauchy sequence is nothing but after certain stage. Don't bother about some finite number of terms. After certain stage, all the sequence members are very close. And here the sequence members are integers. Then what is the sequence? How the sequence look like? So after certain stage, the difference between two sequence members are very small. Very small means what? Whatever small we want, you can find the stage. If you take epsilon equal to 1 by 2 or 1 by 100 or 1 by 1000, you can always find a stage such that after certain stage, the difference between any two integers. So difference between any two integer.
So it's not possible, no, sir.
Oh, it's possible. Why? If you take
The
constant,
distance is always one only, no, sir.
yeah, if you take all the numbers, suppose I'm taking sequence 1 1 1 1. Okay, all the sequence are 1 1 1. What is the distance between any two terms? Is 0. Right? Is less than epsilon. Epsilon is positive. Right?
Yes, sir.
Or you can take 2 2 2 2. Then what can you say about this xn? So suppose I'm taking first, no, it need not be constant. Suppose I'm taking 2 2 2. and then 5, 5, 5. After that, I am taking everything is 1, 1, 1, 1, 1. This is not a constant sequence because we have 3 constants there. But this finite number of stage, so I already said that after certain stage, therefore don't bother about the some finite number of terms. So finite number of terms may be anything, any integer. But after certain stage, everything is the same number. That type of sequence is called eventually sequences. So eventually sequence is nothing but after certain stage, everything the same number. That is eventually sequence, eventually constant sequence. Eventually constant sequences. So when we say a sequence is eventually constant sequence, after finite number of stage or after finite number of terms, all the sequence numbers are same number. Such a sequence is called eventually constant sequence. Constant sequence means what? From the first term itself, we have same number. From the first term, second term, all the terms are same number. We call it a constant sequence. But eventually constant sequence is nothing but after certain stage, all the numbers are same. Now this is a, now tell me that xn is a constant sequence or eventually constant sequence? So because the definition constant sequence after certain stage, all the sequence numbers are very close. Therefore, don't worry about the first few terms. Therefore, I can take anything for the first finite number of terms. Therefore, but after that, we have to take the same number. Therefore, should be eventually constant sequence. Is more powerful. So if you say constant sequence, but more powerful that it should be eventually constant sequence. Okay, so this is very important thing. So they will check you understand the Cauchy sequence or not. They will ask question like this. Suppose xn is a Cauchy sequence of integers, then what can you say about the sequence? Okay, therefore the distance between any two integers are very small, means what? That two integers should be same. Therefore, after certain stage, all the sequence numbers are same. That means such a sequence is called eventually constant sequence. Okay, it's very important. Okay, now the next problem. Suppose we have a sequence xn and a is any number which is positive, which is greater than 1, and this xn satisfies the condition modulus of this xn plus 1 minus xn is less than a power minus k, where a is positive or that is bigger than 1. So this is true, sorry, k plus 1, or this is n, a power n minus n. So this is true for every n in n. Then from this we can say that this xn is Cauchy, implies xn is Cauchy. So that means what? Actually, already we know that a is bigger than 1. So what is this a power minus 1 by n? Minus n is nothing but 1 by a power n. This, okay, correct? So this is nothing but 1 by a whole power n, because 1 power n is nothing but 1. So this a power minus n is nothing but 1 by a power n. So a is bigger than 1, then what can you say about 1 by a? 1 by a is less than 1. Okay, so 1 by a is smaller than 1. If you raise the power, this approaches to 0. If, for example, if you take a equal to 2, okay, if you take a equal to 2, then what is 2 power minus n is nothing but 1 by 2 power n. We know that this converges to 0. So therefore, similarly, so ultimately here, so this term converges to 0. Okay, therefore we get less than epsilon. So modulus of this a power minus n is less than epsilon because this converges to 0, and this is less than or equal to this. Therefore, this should be less than epsilon. So what is the state? So we can easily prove that xn is Cauchy. Got it? So any doubt in this? So because the right hand side we have a, so this is nothing but a sequence converges to 0. Therefore we get less than epsilon. Therefore xn plus 1 minus xn is less than epsilon. But we need a general term. So how we'll get the general? That is, we need xn minus xm. We need the distance between these two numbers is less than epsilon, right? So assume that m is bigger than m. Therefore, suppose I am taking n is bigger than m, so therefore this n is of the form m plus some number. Okay, therefore I can write e instead of m, we can k mk plus 1, sorry, xm. So actually xm is there, and then xm plus 1, xm plus 2, etc. xm plus k. So subtraction of this nothing but I am just adding and subtracting these numbers, remaining numbers, adding and subtracting. And then I take the triangle inequality, I will get this like next two numbers, xn plus 1 minus xn. Okay, therefore finally we get, because each one is less than epsilon, therefore if you want you can take epsilon by k. Therefore epsilon by k plus etc. epsilon by k times you get epsilon. Okay, so suppose a sequence satisfies the condition that the next two elements of the sequence xn plus 1 minus xm is less than a power minus n for all n where a is greater than 1, then xn should be Cauchy sequence. Okay, we can easily prove this is Cauchy sequence. Why? Because this sequence is converges to 0. That's why this is a Cauchy sequence. Okay. Now, the next problem. So these are all very important. Simply they will give this condition. They will ask is a Cauchy sequence or not. Okay. So next theorem. Suppose we have a sequence xn. This xn satisfies the condition that modulus of xn plus 1 minus xn is less than or equal to c times modulus of xn minus xn minus 1. Okay, where c is some constant, but c lies between 0 and 1. Such a c exists, satisfies this condition, then implies that xn is a Cauchy sequence. Xn is Cauchy. So suppose you want to check a sequence is Cauchy, either you can use the definition, or we can check this inequality, or you can check this inequality. If this is bounded by some a power minus n, then xn is Cauchy. Or if you prove this inequality for some c where c lies between 0 and 1, then xn is Cauchy. So these are all, can easily check that a sequence is Cauchy sequence or not. Okay. So any doubt in this? Okay. So next, monotone sequence. And when we say a sequence is monotone, so monotone means for either increasing or decreasing. So when we say a sequence is increasing, all the terms are increased. So that is, so next we're talking about monotone sequences. Monotone sequences. So either increasing sequence or decreasing sequence, we say is a monotone sequence, either increasing or decreasing. So first we define what is increasing sequence. Definition, we say a sequence xn is increasing, a sequence of real numbers. Okay, because we are going to compare the numbers, so where the comparison holds only in the real case, because we cannot compare two complex number, because we cannot say suppose we take 2 plus 3i is one complex number, 5 plus 2i is another complex number. We cannot say this is less than or equal to this, or this is greater than or equal to this. We cannot compare two complex number, but we can compare two real number. That's why we need a condition, this xn of a real sequence, real sequences, real numbers. We say a sequence of real numbers is increasing if for any n in n, xn is less than or equal to xn plus 1, is increasing always. The first term is smaller than the second term, second term is smaller than the third term, and so on. So if it is increasing, then we say it's increasing sequence. Similarly, for decreasing, so similarly, when we say a sequence is decreasing, if for any n, in n, xn is bigger than x n plus 1, xn plus 1. Such a sequence is called decreasing sequence. Okay, so similarly, we can define strictly increasing. Strictly increasing means what? Strictly less than. Strictly increasing if for any n in n, xn is strictly less than xn plus 1 for all n, then we say strictly increasing. Similarly, we define strictly decreasing if you take any n in n, all the sequence members are satisfying this condition. Xn is strictly greater than xn plus 1, then we say the sequence is strictly decreasing. Okay. Now, when we say a sequence is monotone, so a sequence is said to be monotone if either increasing or decreasing. Either increasing or decreasing, but not both. Either increasing sequence or decreasing sequence, we say it's a monotone sequence. So again, when we say a strictly monotone, is either strictly increasing or strictly decreasing, we say strictly monotone. So strictly monotone, a sequence said to be strictly monotone if either strictly increasing or strictly decreasing. Strictly decreasing. Okay. Now, when a monotone sequence or increasing sequence converges, okay, that is very important theorem. So we know that the sequence is increasing. So when the sequence is converges, that is the theorem. The theorem says, suppose we have an increasing sequence. So let xn be an increasing sequence. Then it is suppose converges, then it is converges. So then what can you say about the sequence? It is converges. Convergent. If and only if. Then what can you say about the sequence? Can anyone? So it's increasing. So that means what is going on. But it converges. Then what can you say about the sequence? So converges means already we know that all the convergent sequence are bounded sequence, right? Got it or not? Every convergent sequence is bounded sequence, but the bounded sequence need not be convergent. Now this is increasing. It's increasing going on. But I am saying that it is convergent. But I know that convergent sequences are bounded. So we can find a m such that all the xm's are less than or equal to this m. That means what? We have an upper bound for this sequence member. Therefore, it is bounded above. But we don't know about the lower bound. Therefore, so it is bounded above. It is bounded above. So when an increasing sequence is convergent, if it is bounded above. If an increasing sequence is convergent, it should be bounded above. So similarly, a decreasing sequence is convergent, it is bounded below. Okay. So the next theorem, if you have a decreasing sequence, if it is converges, then if and only if it should be bounded below. Then that means what? We have a lower bound for the sequence. That is the next theorem. So let xn be a decreasing sequence. Decreasing sequence. Then it is converges. Then it is convergent if and only if it is bounded below. If and only if it is bounded below. Okay. Because converging sequence are, again we know that is bounded. So the sequence are decreasing. So going this way, decreasing from negative side or somewhere is decreasing. But its convergence therefore is bounded. So bounded by some number. Therefore, the sequence is bounded below by m, but we don't know what is the bounded upper bound. We have a lower bound m. Therefore, these sequence numbers, and if you collect the set of all xi's, that set bounded below by m. Therefore, it's bounded below set. The sequence is bounded below. Okay, got it? Okay. So, okay. Any doubt in this? So therefore, if a increasing sequence is convergent, should be bounded below, or a decreasing sequence is bounded below if and only if it is convergent. It should be very important. Okay. So sometimes we use the notation to denote increasing, decreasing is. So suppose we denote this xn, this notation, this arrow x. So that means what? Xn decreasing converges to x. Okay. And suppose I am writing xn, this arrow x. That means what? Xn is a increasing sequence, converges to x. Okay. So this means decreasing and converges to x. So this arrow means increasing. And this straight arrow means convergence. We don't know about the sequence, maybe increasing or decreasing or both combination of increasing and decreasing, but this direct arrow denotes the still convergence. But this increasing convergence, and this means strictly decreasing, sorry, not decreasing and converges to x. Okay. Now I state some important examples of a sequence. We can use that sequence to show other sequence converges or not, and then we can find the limit of other sequences. So what are the important examples are? So the first example, if we take any number which is less than or equal to 0 or positive and strictly less than 1, now we define xn is r power n. Okay, if you take any number which is lies between 0 and 1, if you raise the power n, that is a sequence. Now, as n goes to infinity, this number goes to 0. So, any number lies between 0 and 1, the power n is always goes to 0. For example, if you take 1 by 2 power n, so this is nothing but 1 power n by 2 power n, just 2 power n. This converges to 0 by this result. Okay. If you take r equal to 0, 0 power means 0, that is trivial, right? So if you take 1 by 3 power n is also converges 0. Then what can you say about 2 by 3 power n? Where this converges? Again, this 2 by 3 is less than 1. Therefore converges 0. Or sometimes they give 2 power n by 3 power n. It's nothing but 2 by 3 power n. So 2 by 3 is a number lies between 0 and 1. Therefore this converges to 0. So any number lies between 0 and 1, that power n always goes to 0. Okay, it's very, very important thing. Okay. So the proof is very simple. You have to, it's a decreasing sequence, right? So what is the relation between Rn plus 1 and then Rn? So Rn is bigger than Rn plus 1. Because even if we take 1 by 2 case, R equal to 1 by 2, so 2 power n is less than 2 power n plus 1. Because the power is bigger, therefore 2 power n plus 1 is bigger. Now take this side, 2 power n plus 1 is less than 2 power n, sorry, 1 by 2 power n, right? 1 by 2 power n. So this is nothing but xn. So this is nothing but xn plus 1. In general, I am writing here Rn is bigger, R power n plus 1 is bigger. That means what? Xn is bigger, strictly greater than Xn plus 1. That means what? This R is a decreasing sequence. This Xn is a decreasing sequence. Sorry, yeah, decreasing sequence. Right? It's a decreasing sequence. What is the lower bound? 0. So therefore, by previous result, this lower bound as converges to lower bound. Therefore, this Xn converges to what is the lower bound of the sequence? 0. So simply we can prove. Okay. So it's very important sequence. If you take any number lies between 0 and 1, strictly less than 1, that is very important. That R power n converges to 0. Now, the next example. Okay. So the second example, if you take our new sequence Sn is sum of this 1 plus r square plus etc. plus r power. Suppose I am taking n. So r is, suppose I am taking r is anything. Okay. Now, what is the value of this one? So how to find the value? So we don't know value. Suppose we call x equal to this. So already you know this. This geometric series like this. Suppose I'm multiplying r again. So r times x. I multiply r both side. We get r plus r square plus etc. plus r power n and then r power n plus 1. Now just subtracting these two. So therefore this x minus r times x this side. So this r and this r cancel and so on. Everything is cancelled. This r power and r power cancel. Therefore the remaining things are 1 minus the last term r power n plus 1. Therefore you can take x outside. We get 1 minus r equal to 1 minus 1 minus r power n plus 1. Therefore, what is x? This one. Therefore, what is the value of this is nothing but 1 minus r power n plus 1 by 1 minus r. Okay, this is a value actually. Sn is nothing but the sequence 1 minus r power n plus 1 by 1 minus r. Now, when this converges to 1 by 1 minus r, provided this number goes to 0. If this number goes to 0, then this converges to 1 by 1 minus r. So when this number converges to 0, provided the modulus of r is less than 1. It should be less than 1. So that is a geometric series. Okay. Therefore, this sequence converges to 1 by 1 minus r if, it's very important, r is less than 1, modulus of r is less than 1, then this sum 1 plus r plus etc. r power n converges to 1 by 1 minus r. This is a very important result. This Sn converges to 1 by 1 minus r, provided modulus of r is less than 1. Is very important. Okay, using these, we solve many problems. Okay. So okay, now I state some problems and then I say that what is the limit. Suppose xn equal to, I am defining 1 by n plus 1 plus 1 by n plus 2 plus etc. plus 1 by n plus n, I am taking 2n. So this 2n is nothing but n plus n, the nth term. So this I am defining xn. Show that xn is convergent. Show that xn is convergent and its limit is 1. Converges to 1. At the most, converges to some point. That point is less than 1. So converges to at most, limit at most 1. Converges to a limit at most 1. So that is, we have to prove that xn converges to some x, but this x is less than or equal to 1. We have to prove. So this will look like some geometric series. We can write in the form of geometric series and then try to prove. Otherwise, you have to show that either increasing or decreasing and converges. So this is xn. Then what is xn plus 1? So simply I am taking x1. What is x1? Substitute n equal to 1, we get x1. So therefore x1 equal to So we get to up to 1 by 2 we get, therefore just 1 by 2. So what is x2? x2 means up to 1 by 4. So therefore 1 by 3 plus 1 by 4. So this is x2, right? Now what is the difference? What is the difference x2 minus x1? So this is nothing but modulus of 1 by 3 plus 1 by 4 minus 1 by 2. So this is actually 1 by 4 minus 1 by 2 is minus 1 by 4. Therefore we get 1 by 3 minus 1 by 4, right? Because this is half and this is called therefore quarter, therefore we get this one. So if we simplify these, what is this? Is 12 1 by 12, correct? Anyway, we get this value is 1 by 12. So actually what I am going to show that I am going to show this xn is either increasing or decreasing. Anyway, so no need to go this anyway. So we have to check which one is smaller, x1 or x2. x2 value is this. What is this value? 4 and 7 by 12. Okay. Which one is smaller? Which one is bigger? 1 by 2 is smaller than 7 by 12? No. Yes, because if you multiply here 12 and if you multiply here 14, yeah, x1 is strictly less than x2. Then what is x3? x3 is nothing but 1 by 3. N equal to 3 means x4, x5, x6, 1 by 6. So again, clearly x3 is bigger than x2. So we can easily show that this sequence xn is a increasing sequence. So when the increased sequence converges, it is bounded above. So what is the maximum bound? Everything is lies between, everything is 1 by something, right? So everything is 1 by something, 1 by something. Therefore, always lies between 0 and 1. All the sequence values lies between 0 and 1. Because even if you take x2, x1 is 1 by 2 here. x2 is 7 by 12. Anyway, is less than 1, therefore somewhere. And then if you simplify these, again you get some value is less than 1. So all the x's are within this interval, and this is increasing sequence. Just now we proved that this is increasing. x1 is bigger, smaller than x2 and so on, increasing. So the sequence is increasing and is bounded by 1. Therefore, converges to the bounded above. Therefore, at the most converges, but should be less than or equal to 1. Got it? So first we have to prove that this xn is an increasing sequence. So how to prove increasing? So better take xn and then xn plus 1. If you take two sequence and then we have to check, so show that xn is smaller, xn plus 1 is bigger in general case, but I am checking x1, x2, x3, but you have to prove in general xn is less than xn plus 1. I say increasing sequence, and every sequence is always lies between 0 and 1, therefore is bounded above by 1. So usually, suppose a sequence is increasing and it is bounded above, then it is converges to the upper bound. Suppose a sequence is decreasing and it's bounded below by some number, then the sequence is converges to the lower bound. So that is the idea. At the most one. So it's the converges to some point, that point is bounded by that number, bounded upper bound. Now, the next problem, suppose we have a sequence and xn is a positive sequence, all are positive sequence, and this xn plus 1 by xn. So the next two terms, xn plus 1 by xn, suppose this converges to L, and this value L is less than 1, implies that we can say this xn should converges to 0. This is very, very important result. Suppose we have to find xn plus 1 by xn. If the limit value is L, that L is less than 1, then the sequence is converges to 0. So for simple example I am taking, suppose if you take xn equal to 1 by 2 power n. Now what is xn plus 1? Replace x by n by n plus 1, therefore 2 power n plus 1. Now I am going to find what is xn plus 1 by xn. So this is nothing but 2 by 2 power n. So we can reverse, we get this one. Okay, so we can cancel 2 power n, 2 power n, we get 1 by 2. 1 by 2 is less than 1. So by this theorem, Anyway, we know we don't take any limit because there is no n here. So everything cancel. We can say just a constant is converges to 1 by 2. Therefore, this value is 1. Therefore, we know that 1 by 2 power n converges to 0. So if you take a positive sequence xn, and then if you consider the new sequence xn plus 1 by xn, it is converges to L, and the L value is less than 1, the sequence should converges to 0. Okay. Now, third one. Suppose I am defining an equal to n factorial by n power n. Show that this sequence is converges to 0. Show that an converges to 0. So first, everything is positive because n factorial is positive, n power n is positive. Now check what is an plus 1 by an. So what is an plus 1? N plus 1 factorial by n plus 1 power n plus 1. We have to replace n by n plus 1 and divided by an. So an, therefore, this is n factorial by n power n. It should be in the numerator n power n. Now, this n plus 1 factorial can be written as n plus 1 into n factorial into n power n divided by, you can take n from this one, therefore n power n plus 1, you get 1 plus 1 by n power n plus 1 into n factorial. Now we can cancel this n factorial, and then we can cancel this n power n power n. Okay. So what you'll get? Remaining things. N plus 1 by n into 1 plus 1 by n power n plus 1. Now again we can take n outside from the numerator, therefore 1 plus 1 by n by n into 1 plus 1 by n power n plus 1. Therefore this n cancel. Now n goes to infinity, this goes to 0, therefore numerator we get 1 by, actually this goes to e, and the e is that number. So this an converges to 1 by e. Okay, I did some mistake. It's not converges to 1 by e. But I did some mistake. Okay, this 1 by e value is less than 1, right? So not an plus 1 by an plus 1 by an converges to 1 by e. 1 by e value is less than 1 because e lies between 0, 2 less than e less than 3. We know this. Therefore, consider this. Therefore, 1 by e less than 1 by 2. 1 by 2 is less than 1. Therefore, the limit is e is less L is 1 by e. This is less than 1 by the previous result that given sequence converges to 0. So therefore, you should know the value. So,
Sir, how did we get 1 by e, sir?
We want to know this one. So limit n goes to infinity, the sequence 1 plus 1 by n power n. So this sequence actually converges to e, the standard result. Okay, we can easily prove it. Not easily prove it. It's a standard theorem. Okay, so this here n is nothing but e. Suppose, but we have a 1 by n power n plus 1, but this can be written as 1 plus 1 by n power n into 1 plus 1 by n power 1, because base are same, we can add the powers, right? Now this goes to e, but here this goes to 1, so e into 1 is e. That's it. But it is in the 1 by something, therefore it's converges to 1 by. So any doubt in this? Any doubt? Okay, I can stop now. Thank you.